welcome to this episode. So what we are doing is we are doing electrolysis. So the laws of electrolysis. So we have two laws of electrolysis. We have the Faraday's first law of electrolysis, and we also have the second Faraday's second law of electrolysis. So we are going to start with Faraday first law of electrolysis. Now let's dive into it. So now Faraday's first law of electrolysis says that the mass m of a substance liberated, deposited, dissolved at an electrode during electrolysis is directly proportional to the quantity of electricity Q passed through the electrolytes. That is, so what they are trying to tell us is that mass is directly proportional to the quantity of charge. I hope you understand. So the mass, now when you want to remove the equality sign, what's normally happening? You'll be putting K, right, in mathematics, but instead of putting K here, we will not be putting K, we will be putting Z instead of K. So it means the Z here is a what? Is a constant. I hope you understand. So now what is the meaning of Q? So Q is the quantity of charge, and Q is what? Is equals to height C, that is the current times the time. I hope you understand. So why this Z? So now we can now say M now is equals to, you can now say M will now be equal to Z I T. That's the formula for what? The mass for electrolysis. So that's the first law of electrolysis. Now let me state what each of them means. So the M, you already know that M represents the mass measured in kilogram, but some of the time it will be in gram, though I will tell you the aspects you are going to be using gram. So Z is the electrochemical equivalent, but most of the time in physics it should be in kilogram, but in chemistry, when you are using this formula, you will be converting to kilogram. But most of the time when I'm using this for you, you will not need to convert to kilogram. So the Z is called the electrochemical equivalent. So you may just write it like EC. So in some questions. So why the time T? So that's the time, and you already know what I is always current. So current is what? Ampere. Time in seconds. So Z, you already know what Z will be like that. So Z will be M over Q. What's unit for mass? Kilogram. What's unit for charge? Coulomb. So the unit for electrochemical equivalent will be gram per coulomb. So that's it. So that's the unit for electrochemical equivalence, and the unit of mass is kilogram. But you must convert to kilogram. When they give you gram, you convert to kilogram. But most of the time in the question, I've told you that the ones we'll be doing, you'll be using gram in chemistry most of the time. And also it depends on the value of the electrochemical equivalent. Though you don't need this for chemistry, but in physics, most of the time you'll be using this formula. So let's go to the next aspect now. Okay, let's go to the next law. So now let's go to second law. The second law states that the same quantity of electricity is passed through solution of different electrolytes arranged in series. They said the relative number of moles of the element deposited or liberated are inversely proportional to the charges on the ions of each of the elements respectively. So mathematically we can say M varies IO 1 over E. It is not IO 1 over E. So and our N is our number of moles, and our E is the word charge on the ions. Hope you understand. So our E is what? Is the charge of the ions. So that's it. So now this is the equation for it. When M, it carries S plus XC. So when M carry mx plus xz minus, so it will be equal to M. So it means whatever it carries will be what you are going to add. If it is Na plus, you know that one is 1. So your number of mole here will be what? 1. You also be having so it means 1/5 farad means 1 electron. You know that this place we didn't write anything. I didn't mean we write 2e, so it means that will be 2 farad. But here just 1. Just 1, we don't write it. You don't need to write it whenever it is 1. So this carries plus, so it will be 1 here. If it carries any 2 plus, it will be 2e minus. I hope you understand. So let's go to some examples. Let me show you. So if you see it now, here in the calcium, because it carries 2 plus, the number of electron gained will be what? 2e minus. Look at the aluminium also. It carries 3e minus. It carries 3 plus, so 3e minus. That's what we had. Now there's something. Whenever you are working on, if they ask you how many, if you want to now do it now, for if you look at this is 1 mole of aluminium, right? And this is 3 farad. I hope you understand. This is 3 farad, this is 2 farad. Though they say 2e minus, it is also 2 farad. So this place will be 2 farad of electricity, gives rise to what? 1 mole of Al. Similarly, here also you can say 2 farad give rise to 1 mole of calcium. I hope you understand. So that's this. So let's go to the example now. They said the solution of copper 2 tetrasulfate 6 is electrolyzed with a current of 6 ampere flowing. So let's write our parameters out. They give us time. Our time is what? 5 hours. Calculate the mass of copper deposited. So that's what they just gave us. They gave us mass. They now say we should find what we should calculate the mass that is deposited. Now this is what we are going to be using. We are not going to be using this formula mainly. We are not going to use it. What we are going to be using is just this and this. And now is that if you just say Q varies is equal to what? M. I hope you understand. Now 1 farad, they always give you in the question that 1 farad is what? 96,500 coulomb. And coulomb is what? Is the unit for what? Charge. So it means your coulomb will be under this side. I hope you understand. Now they've given us the way to find. They give you coins, they give you time. You should know that what they want you to find there is what? Is the Q. I hope you understand. I hope you understand the logic. Now because they say you should find the Q, let us find the Q. So Q will now be what? IT, right? Now what is our T? They said 5 hours. You know that 5 hours is not the SI. Hours is not the SI unit for time. So you need to convert time to seconds. So we multiply it by 3,600. I hope you understand. So that's how to do that. So let me quickly calculate that. So that will now be what? That will be 18,000 seconds. That's the time. Now our current now will be 6 times our time, 18,000. So that will now be what? That will be 108,000 coulomb. So that's the quantity of charge. Now you see that I said Q will be on the same side. Now we are getting to Q. I hope you understand. So what we are going to be doing is that on one side they said 1 farad gives us what? 96,500, right? So now if you look at copper, they said copper 2. So copper 2 means Cu2 plus. I hope you understand the logic. And I told you earlier that when something carries Cu2 plus, it will be plus 2e minus, gives us what? Cus. I hope you understand. So it means this 2e minus what? Represents what? 2 farad. I hope you understand. Now you will now say 2 farad is what? It will give us this what? This copper. So that will be the molar mass of copper. So that will be 63.5. Now these 2 farad represent the what? The coulomb. So now the other coulomb now that we get, you will now write it. So it will now be what? 108,000 1000. They now said we should find the mass, so it will now be x. I hope you understand. Now they now said 1 farad is 96,500. So it means for this place we are going to be writing what? We are going to be writing 2 times 10 raised to power 2 times 96,500. That's what we'll be writing. So you just cross multiply. So we'll be having 2 times 96,500 x, which is now be what? 63.5 times 10800. So let me just give you this final answer. So you now say 2 times Kineka. So sorry about that. I need to look for a space now. So we now have what? So our final answer for x now will be, our final answer for x will be 35.53. So after pressing your calculator, that will be your final answer for x. I hope you understand the way we did it. Your q, they will be on one side. Your m also, they will be on the other side. So we now look for the other m. So that's how to do it. Now let's do the second question. So they now said calculate the mass of lead that will be deposited from an aqueous solution of lead 2 salts by the same quantity of electricity that deposits 2.7 gram of copper from an aqueous solution of copper 2 salts. Now they are talking about 2 elements. They are now talking of that of copper so that you can use it to find that of lead. I hope you understand. So for you now to do this, you will just say you will firstly find the mass, you will find the quantity of electricity for that of copper, because they said the same quantity of electricity, they already give you the mass for copper. So here we'll be looking for what? The quantity of electricity for what? For copper. Now don't forget that it is what? Copper 2 ion. So it means we are still going to be using what? 2 farad. So 2 farad is what? 2 times 96,500. It gives us what? You'll be equating it to the molar mass. Then here also, they've given us the mass, 2.7. So we are looking for what? The Q. So that's what they're asking us to find. So they ask us, they have the same quantity of electricity. And they didn't give us that quantity of electricity that passed through copper. So it means after getting the quantity of electricity that passed through copper, we are now going to equate it to that of the lead, so that we can use it to get our answer. So let's cross multiply this. Let me quickly. So the final answer will be 63.5 Q. Now be 2.7 times 2. So we now have 63.5. So let me now tell you the final answer. So the final answer for that aspect is 820.6.299. So that's the in column. Now they now say the same electricity passed through that of lead, and they also say lead too. So it means the quantity of electricity Q is equals to M. So lead 2 also will be 2 farad equals to what? So 2 farad will be 96,500 equals to that of what? The mass. They're asking us to find the mass of lead. It will now be no. It will be the molar mass of lead now. You should note that any place you have 2 farad, it will be equating to the molar mass. So that's the logic. Any place you have the 2 farad, it will be equating to the molar mass. Why the other mass, which is not the molar mass, will be below. I hope you understand. So now we be having the quantity of electricity that passed through copper. I said the same electricity pass, so it means 820.299. We now pass through what? They now say we should find the mass, so this place will be mass. Let's cross multiply. So at the end of the day, okay, let me check. So let me just do the final answer. So you can just, so our x, which is the mass, or x is equals to what? So let me quickly do the final answer. So that will be what? 8.80 gram. So let me now do the last question. They now said 0.66 gram of a divalent metal is deposited when a 1.35 ampere is passed for 1500 seconds through a solution of the salt using inert electrodes. Calculate the atomic mass of M. So this question also is one of these simplest questions. So they say divalent elements. Divalent element are element that carries 2 plus up on their head. I hope you understand that they carry 2 plus, so they are divalent elements. So that's what they are asking, trying to tell us. So they are what? The element that carries 2 plus A on them. So adding being the element is element. So they said element metal M, so it will be 2 plus. So it means 2 plus is automatically 2E minus, and 2 minus is what? 2 farad. So there is no big deal in the question. So it will now be 2 farad now is equals to, they ask us to find the molar mass, and I told you whenever you're having 2 farad, you'll be equating it to the molar mass. I hope you understand. And so that's it. They now gave us the current. Let me check what they gave us. The current of 1.35, and they gave us time also. They've already converted it to us 1500. Then now, so you know that we find the Q, so that will be 1500 times 1.35. So that will be what? So let's quickly do that. So we have in 2025 column. So that's the Q. And don't forget the way we do Q is equals to M. Now 2 farad, I told you it will be equals to the what? Molar mass. And the molar mass is what we are looking for. Let's say the molar mass is M. So now we already have our Q, which will be on this side, 2025. And then what will be here? So they've already given us the other mass, which is 0.66. It's already here. They are talking of this. So it will be 0.66. So just cross multiply. So we are now going to have 2 times 96,500 times 0.66 over 20.25. Okay, 2025 is equals to the molar mass M. So that will be our M. So now, what is our final answer? So our final answer will be, let me quickly do that. That will be 62.904 gram. So that's the molar mass for element X, that's the divalent element.